All right, we're here. This is week 2 of distance learning, and we're going to start a brand new chapter. And so we're going to do pretty much everything just like we would be done in class. We're going to start chapter 10 in just a little bit. Just kind of want to go over how the schedule is going to be for potentially the rest of the school year, the 2020 semester anyways. Every day from 9 to 11, I'm going to be making videos. So hopefully I'll get ahead of the game where we'll have, I'll be making videos for the future, and so you always have stuff. So every day there'll be a video that you're going to be required to watch. Depending on questions, I might have a video separate every day just to answer questions. So when you email me questions, more than likely what I'm going to do is I'm going to answer questions in a question and answer video. That way I can have paper and I can have maybe the problem and hopefully get it solved with it. If it is an easy question, I'm just going to email you right back. If it is a question that a lot of people need to hear, I'm going to use my videos to answer those questions. So just be aware of that, and be aware that we'll have a question and answer video either added on to the regular video, or if it's too long, a separate video. All right. Every day from about noon to 2 is when I'm going to mainly deal with emails. So noon to 2. So if you email me after 2, I'm probably not going to get it to the next day. If you email me before noon, I'm probably working on videos and making sure that you have work and things that you need to do. All right, so that's basically the announcements for the week. Not for the week, for the day. Make sure that you're getting your stuff done every day. I'm going to set a due date for Sunday, but I wouldn't wait till Sunday. I'm not going to be around to answer emails on Sunday or Saturday. So I would get today's work done today, even though I'm going to set the due date for Sunday. Okay, so we're going to start the circle chapter. Okay, and so your directions should have said in your Google Classroom, before you even watch this video, you're supposed to turn to page 476, and you're supposed to write down all the definitions, and you're supposed to write down the 2 theorems. So if you haven't done that, go do that. That's supposed to be in your notes, and we are going to take a note grade. Even if we stay distance, there is a way that I can take your note grade, and I'll let you know how that is, how I'm going to do that later. But that is still going to be a test grade. That is still going to be something that we're going to factor in. And so I'm probably going to pick a section and have you take a picture of that section and send it to me. And I'm going to pick that section based on whatever I feel like. So make sure you're doing these notes that I say so I can make sure that you're going to get your full grade. And that should help a lot of you guys. Alrighty, let's go ahead and get started with 10.1 circles. Alright, here is my circles. I've got some coins here to help me make my circles. And so you should already have your definitions done. So we're going to kind of draw them out so we can kind of see them. All right, first of all, when we name a circle, we need a center point. And we're going to have that center point have kind of a name. And so I'm going to call this one K. And so we can write 2 ways to call this. We can write this circle, K, or we could write this circle, K. Okay, kind of looks like OK, but it has a little dot in it because that's what circles need to be identified as circles. Because a circle is a set of all points in a plane that is equidistant from the center. And of course, so those points are all the same distance from the center. And that distance from the center has another name. So I'm going to just draw that out here. That center is called the radius. So make sure you have a radius. I'm going to call it R for radius. And of course, if you go all the way through the circle, that's no longer a radius. It's 2 radius, or 2 radii. We're going to call that the diameter. And then we have a secant, which you probably haven't gone over before. Secant is a line that intersects a circle with 2 points. Okay, so anywhere. So technically, that's a point and that's a point. So I guess that would be a secant, but also this would be a secant. See how it intersects with 2 points? Okay, and a tangent intersects the circle at one. Let me put this secant. A tangent is going to intersect at exactly 1 point. So that's a tangent, and yes, this is the same tangent that we did in trig. We're not going to get into why the tangent for a circle and the tangent in a trig are the same thing. You're going to have to do that in your Algebra 3 honors class. And they'll go over that. And so the point of tangency, of course, is, that guy right there. Okay. So that's basically the parts that I need you to know of the circle. And this is how you're going to understand the questions that are coming to you. Okay. So we also have coplanar circles and common tangents. Okay. And so there's different ways to do that. There's a pretty good example in your book. But I'm going to go ahead and do the tangent circles. Okay, so we can have 2 circles here. Okay, and I'll put another circle over here. And we're just going to draw kind of a tangent here. I'm going to put my point of tangency so you can kind of see it. And I'm going to call this circle A and this circle B, because if it doesn't have the middle, it's not really a circle. Okay, and so there's our points of tangency. Okay, and so we're going to have a couple questions dealing with this. This would be an external tangent because it's outside the circle. If we had a situation, I'll draw it real quick, like this. Well, if we had a circle like this, we could have a tangent right here between the line where they both have 1 point of tangency. That would be an internal tangent line. All right, so we're going to move on from that. I think we got all of that stuff done. Okay, a line or segment that is tangent to 2 coplanar circles is called a common tangent. So that would be a common tangent. That would be a common tangent. All right, let's mainly look at the theorems. And again, this is not going to be a proof chapter for us. This is going to be a mainly dissecting the shape and figuring out which theorem or which kind of formula to use. It's kind of formula. So we got 2 theorems, 10.1 and 10.2. So 10.1 is a tangent line to circle theorem. Okay, in a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle. Okay, it says if and only if, which means it works both ways. So it can work backwards and forwards. Okay, there's my circle. And we're going to draw a radius and a tangent. And basically what this is saying is we have a tangent here, and we could draw a radius to tangent and make it perpendicular. And so the point of tangency to the center of the circle is going to be where we draw a radius, and that is going to be perpendicular, and that's going to work that way every time. Okay? Okay, 10.2, this is 10.1, so I'll label that. 10.2 is the external tangent congruency theorem. Okay? So I'm going to get another circle going here. And then I basically need to put that circle kind of in an ice cream cone. Oops. Well, that's terrible. Terrible, terrible, terrible. All right. Well, let's start over then. I messed that one up because I didn't really draw a tangent. I drew a secant. Let me draw a bigger circle. Maybe that'll help. All right, let's see if we got that end page. All right, there we go. So external tangent congruency theorem states tangent segments from a common external point are congruent. Okay. So I'm going to kind of write this kind of algebraically. I'm going to call this x. I'm going to call this y. Okay, because in your book, which you can clearly read, which you already supposed to have written down, is in geometry. So I just want to kind of show you this. So these are tangents because they have one point, a point of tangency right here. And so basically it means, you know, if we call this AB, we call this AC, it means AB is equal to AC, or in my case, X is equal to Y. All right, that's basically it. So now I'm going to move on past this point kind of to your lesson. So I'm going to go ahead and just scoot this out of the way and put this here. Let's see if we can see the book, because your problems are going to be just straight out of the book. That's what Big Ideas basically is. So we're going to do some little, and sorry about that, but I got to focus it so we can see it clear. So you're going to have to name the circle. Okay, that should be easy enough. It should be what? Circle C. Okay. Name two radii. Okay. So a radii could be AC. Okay. A and CD. Because the diameter is two radii, right? CA, CD. Okay. Order doesn't really matter. So it could be CA, it could be AC. So order doesn't really matter. So that's basically what you're going to do there. Okay. And then we're going to skip down to here. You're going to have something like that. You're going to tell me external, or wait, did I skip something? Yeah, you're going to tell me external, or you're going to tell me internal. So we're going to do some of those problems. So here's where we really get into it, into the mix here. So you're going to have problems like 19, and this is where we might have some questions that I might need to answer. Okay? And a lot of times on circles, the biggest thing that people are going to need to know how to do is they're going to need to know how to add a radius when you need to. So just know that you can draw a radius at any time, because in a circle, all radii are going to be congruent. Because remember, the definition of the circle is the center is equidistant to every point on the circle. So I'm just going to pick one of these and work it. I think this one's easy. I think you can figure 19 out. Okay. And your hand, it says tell whether AB is tangent to circle C. Well, we have one theorem. That one theorem says, I'll just go over it just because normally we would do it in class, so I'm just going to do it. So I'm going to go ahead and move this out of the way and kind of show you what we're doing. Because just because we're doing triangles does not mean we are circles does not mean we're done with triangles. So just keep in mind, we just finished something important. We're not really going to use the trig element in this, but we are going to use the kind of the easier element, the Pythagorean theorem here. So basically, what this is saying, and I'm not even drawing the circle, you don't see that. There we go. And I'm not drawing the circle here, but I am going to write the A and the C and the B. 4, 3, 5. So what it is saying is if this is a right angle, which I don't know if it is yet, then AB would be a tangent. Okay? So how do I determine if that's a right angle? Well, I do small side squared plus medium side squared, and we're going to see if that's going to equal the hypotenuse 5 squared. Okay, let's just go ahead and do that real quick. 25, 9, 16, 25 equals 25. Okay, that is a right triangle. Okay, and since that is a right triangle, that means that's a right angle, which means AB is a tangent. So you're going to have to do that. So just because we've moved on doesn't mean we've moved on. That's kind of the theme of geometries. We're always using stuff from the last couple chapters. All right, let's do a harder one like 21. And I don't know what it's going to be in your book, but let's do a harder one like 21. You're going to have this one exactly in your stuff. I'm going to set this up real quick. Let's get a nice circle going. All right, and I'm going to start labeling stuff. Well, I wish I didn't put that there. I can trick it. I needed more room on that side, so I flipped it over. I'm sorry. Let's see, that's a secant, so we're going to draw it here. Center. And here we go. And so I'm going to label this, just like in your problem. So that's 60. And that means that 60 goes from B all the way to D. So that's 60. All right. This is 20. Okay, and I believe 20 is just from C to D. This is 48. Okay, and 48 is going to be from A to B. All right, so I got a missing piece right here. I know it's 20. Why do I know it's 20? Well, C to D is a radius, A to C is a radius, so that is also 20. So you can fill that in. That's just a little circle knowledge trick. And so we're trying to determine if AB is a right angle. It's tangent, and the only way it would be tangent if this is a right angle. Okay? So this is a key right here. A lot of people are going to forget this. A lot of people are going to be confused. That's why I make these videos. So let's see if this works here. And this is 21. And so I'm going to go ahead and do this. So short side. Can you see that? Yes. Plus medium side is going to equal, okay. And again, you can just put this in your calculator here. So 600 squared, 600 squared, that's 360. And then we're just going to put in 40 squared plus 48 squared. And that is going to be, so what do we think? Not equal. I could even say this is an acute triangle, but I don't need to. All I need to know is not equal, so guess what? AB is not a tangent. So AB, not a tangent. Okay? And it might not matter if you did this or not on this problem, but it is going to matter in the future. So now I'm going to move on, and we're going to go to the next set of problems. Okay. In your book, this would be 23. It's going to be one of yours assigned. So I want to make sure that I'm covering some of them that you're assigned, so you can get my help and the book's help. So again, I need my special circle tools. And then if you're bothered by what I'm using a silver dollar and a half dollar because they make bigger circles. And this is, make sure I get this right here. Okay, again, we're still going to use that tangent theorem. Okay, that is very bumpy. Still going to use that tangent theorem. So we got, this is R, 16, 24, that's A, that's B, and that is C. So kind of keeping it ABC just so we can do stuff. The directions say point B is a point of tangency, so we know that. Find the radius R. Okay, so we know that point B is a point of tangency. And this is reminding me about some of the stuff on this page. I'm seeing my notes now that there's a lot of quadratics. Let's see if this one is. I'll be very careful of not giving you a quadratic. And so I'm going to set this one up, and you're probably going to get a supplemental worksheet to do on this, just on this second part, so you don't have to do the quadratic aspect of it. So this is yeah. So I'm going to read my own notes and be reminded that probably with what we have left in this year, we don't have time to go over the quadratic formula, which is what you would need to do a lot of these, because the setup of this would be this. To find that, it'd be short side, medium side equals. All right, so we'll have a supplement that doesn't use these, so I'm glad I'm reminding myself right now, so I'm sorry for wasting your time on this video. So we're going to go ahead and move on to 29, because it is a good, and will be on your assignment today. So 29 is going to be set up like this. It is going to be that second theorem. And it's still dealing with tangents. And basically, 29 is, don't make it hard. Okay. It's just this. 2x plus 7 equals 5x minus 8. Minus 5, minus 5. Minus 7, minus 7. You get divide by negative 5, divide by negative 5, and we get x equals 3. Okay, so that's basically what we got to do in this particular problem. There'll probably be, we'll see what we got. I'm not going to give you the quadratics right now. I don't want to get you all frustrated with that. Normally in Oklahoma we don't do these quadratic type problems until later, so don't worry about that too much. I'm going to make your assignment, and when I go over all your emails, I got a lot of emails over the break. If there's any math questions, I'll try to cover that in a supplemental video, but probably that will come out tomorrow. All right. Until next time, yeah, I'll see you. And make sure if you have questions that I need to answer, send me an email between 12 and 2 so I can get to it in tomorrow's video. All right. Bye-bye.